Have you ever wondered why it is that a very small amount of a specific nutrient could have a very profound effect on the human body? I mean, we're really told that nutrients are kind of gross factors that create then cellular function, that we eat these caloric foods that contain protein, carbohydrate, and fat, and they're burned in a process called respiration, and that energy powers our body. And so we think of food and nutrients as this bulk kind of characteristic that constitutes our diet. Yet you might ask a question, how is it then that very small amounts, even milligrams, sometimes even microgram amounts of a specific constituent of food, like a folic acid or like a biotin or like a small amount of a trace mineral, that could be in the microgram levels, or B12, vitamin B12, could have such profound effects on physiology? Well, that is a very interesting question that relates to the emerging understanding of how specific dietary principles or nutrients work at the physiological level. It's now being found that many of these substances not only activate enzymes serving as coenzymes, like we think of the traditional B vitamins, vitamin B1, B2, B3, B6, B12, as activating specific enzymes through their ability to serve as coenzymes, but now we recognize that some of these nutrients can actually participate in the regulation of genetic expression. And they can influence genetic expression at certain regions within our genes, the so-called genome, that are called regulatory nodes. Regulatory nodes are like the metabolic acupuncture points for our control of our metabolism. They're very sensitive regions where a little of something at the right point can produce a larger response than was expected. Now let me give you an example that this might seem more understandable. If we think of the supplementation with omega-3 fatty acids, and you ask what dose of omega-3 fats, eicosapentaenoic and docosahexaenoic, or EPA and DHA, would you generally use as a supplement each day? People would say, well, somewhere around, say, 3 grams a day. That might be a good number. So 3 grams a day, what does that really mean in terms of the whole body effect of that small amount of mass of fatty acids? So then you ask the question, how much fat do we have in the body total prior to the supplementation with 3 grams of fatty acids? So let's assume that this is a 70 kilogram person, just to use an average. That would be like 150 pounds, 160 pounds. And let's assume that they were 20% body fat, which would be a fairly lean person. So that's 20%, say, of 160 pounds, that's 32 pounds. 32 pounds, there's 454 grams per pound, so we would multiply 32 times 454 to get the number of grams in a whole body of fat, and then we would compare that to 3 grams of a supplemented fat. Now you can already see where we're going, can't you? Because if you multiply 454 times 32, and you compare that number, which is going to be in the tens of thousands, to 3, you'll notice that 3 grams sounds like a rounding error. Why would that small amount of fat have any really significant effect on physiology? It seems like it would just be lost in the wash of all the other fat in the body. And the answer to that question is because it's delivered in a certain way, it's not compartmentalized in adipose tissue, and because it's been demonstrated through mechanistic studies now to influence gene expression through regulatory nodes, it has a much higher impact on physiology than you would anticipate just on the small amount of material that's been delivered. Now this is one of the magic things that's emerging out of the contemporary nutrition research, is to understand the systems biology impact of nutrition. Systems biology, not just one enzyme at a time, but the global effect that these nutrients, these specific substances, including phytochemicals that are derived from foods, these plant-derived materials like flavonoids and polyphenols and isoflavones, how small amounts of these materials can have dramatically significant impact on whole body outcome through the effect that they have at regulatory regions for gene expression that then has a systems biology impact on the overall organism. This is a major breakthrough in our thinking, and it helps us to both develop new ways of understanding the role of nutrition. It helps us to understand why a little can have a bigger effect than we expect, and it also helps us to understand concepts of balance, that sometimes more is not better, that the appropriate level at a lower level in balance with a harmonious orchestration with other substances that regulate these expression patterns produces a better outcome than one voice, very loud forte in the orchestra that overwhelms the rest of the players. I think this will help us in our nutritional therapeutics. It'll help us to design personalized nutritional intervention, and it certainly helps us to understand that nutrients can be powerful agents that serve as biological modifiers and can alter and improve function. It's a whole new foundation for our understanding of nutritional supplementation.